Welcome back, everyone. Ready to dive into another fascinating topic in the world of JavaScript.
Absolutely. Always exciting to explore those inner workings.
Today, we're going deep on something that can trip up even seasoned developers, the JavaScript event loop.
Yeah, it's one of those things that once you grasp it, it unlocks a whole new level of understanding about how JavaScript actually works.
Right. You know how you use functions like, say, setTimeout and think, okay, this should happen after this, and then
Yeah,
it doesn't.
happens all the time. And then you're left wondering what's going on.
Yeah, like, is JavaScript messing with me? But really, it all comes down to the event loop.
It's the event loop calling the shots behind the scenes, keeping everything running smoothly, even when things get a little messy with asynchronous operations.
All right, so let's unpack this. For folks who might be new to this concept, let's set the stage first.
Good point. Got to start with the basics.
So we know JavaScript is single-threaded.
Meaning it can only do one thing at a time. Like a chef with just one hand, you can only chop one veggie at a time.
Right, it goes line by line. But then we have things like fetching data from a server, which can take time.
And we don't want our whole program to just freeze up while waiting.
Exactly. So how does JavaScript handle this without causing everything to grind to a halt?
That's where the call stack enters the picture. Think of it as a stack of dishes. You
Yeah.
know,
Okay, I'm visualizing.
every time a function is called, it's like adding a dish to the top of the stack. When it's done, it's taken off. Simple, right?
I'm following. So if we have a function first and then another function second,
And second calls first?
the first gets added to the stack, finishes its thing, pops off, and then second can continue.
You got it.
Good.
That's the call stack doing its job, keeping track of what needs to happen next. But, like you said, what about those long-running tasks?
Yeah, if a function takes ages on the call stack, wouldn't it hold up the entire line?
Absolutely, and that's where those web APIs step in to save the day. They're like those amazing kitchen assistants working in the background.
I love a good kitchen analogy.
They handle tasks separately, so they don't block that main JavaScript thread.
Okay, so it's like having someone else prep the ingredients while the chef continues with the main dish.
Exactly. Functions like setTimeout or fetch, they're not directly part of the main JavaScript engine. They're these external helpers.
So they work behind the scenes, but then where do those background tasks go once they're done?
They don't just barge back in. They go to this waiting area, the task queue. Imagine it like a line of tasks patiently waiting their turn.
Okay, got it. So the call stack is where the current action is. The task queue is for tasks that are finished but waiting.
And here comes the star of the show, the event loop. It's constantly checking, is the call stack empty?
Like a bouncer at a club, making sure there's room before letting anyone else in.
Perfect analogy. And if it's empty, it grabs the next task from the queue and puts it onto the call stack to be executed.
Ah, so that's why even if I set a set timeout to 0 milliseconds, it doesn't necessarily run immediately.
Right. It still has to wait for the call stack to clear and get picked up by the event loop.
So it's more like, hey, as soon as you're free, can you run this?
Exactly. It's about getting in line, not about cutting in line. And this whole system, it's why things might not always happen in the exact order you expect when you're writing asynchronous code.
It's the event loop, managing the flow, making sure everything gets its turn, even if it seems a little out of order.
Now, there's one more piece to the puzzle. We've got this other queue, remember?
Yeah, the Microtask queue. Is it just a smaller queue?
Not exactly. Think of it as like a VIP line.
Oh, so certain tasks get priority access?
Precisely. Microtasks are those super important, time-sensitive operations that need to happen quickly.
Like what?
Resolving promises, certain events that need immediate attention, they get to jump ahead of the regular queue.
So if I have a promise that resolves quickly and a set timeout with a longer delay?
That resolved promise will execute first because it's in the Microtask queue express lane.
Makes sense. It's all about keeping things running smoothly and responsively. So the event loop checks the Microtask queue first, then moves to the regular task queue if it's empty.
Exactly. And this entire system with the call stack, the queues, and the event loop orchestrating everything, it's what makes asynchronous JavaScript possible.
Without it, everything would just grind to a halt anytime we did anything that took a bit of time.
Exactly. It lets your application multitask, even though JavaScript itself is single-threaded. It's pretty ingenious when you think about it.
It really is.
Yeah.
And it's amazing how these seemingly abstract concepts have such a tangible impact on how our applications perform.
Oh, absolutely. Understanding the event loop helps you write more efficient code. You start to think about how to avoid blocking the main thread, how to use promises strategically.
So it's not just theoretical. It's about making your code better, faster, smoother.
Precisely. It's about writing code that truly leverages the power of asynchronous JavaScript.
This has been eye-opening. Thank you so much for breaking down the event loop.
My pleasure. And remember, the more you understand about how JavaScript works behind the scenes, the better equipped you'll be to write truly amazing code.
And on that note, this understanding of the event loop will be incredibly helpful for our next deep dive, where we'll be tackling error handling and debugging.
Ooh, yeah, getting into the nitty-gritty.
Because, let's be real, things don't always go perfectly, and when they don't, the event loop is often right there in the mix. So stay tuned for that, folks.
Can't wait to unravel that mystery with you next time.
See you then.